Okay, what you're looking at here is our Tesla bifilar coil where we used our 5mm copper tape instead of wire, making it very compact and also raising the capacitance of the coil quite some. Our setup here is positive input as far as the function generator is concerned, but we are using an AC sine wave, 10 volts peak to peak, and we're going to do a frequency sweep from 2 kilohertz up to 6.5 megahertz over a period of 10 seconds. The first LED here is bridged straight across our function generator, so supposedly receives whatever the function generator is putting out. The rest of the LEDs here, the other 4, are at various points where we tapped into our windings on our bifilar coil. One thing to keep in mind, we have a 100 ohm resistor here, so the current is limited going into this coil. So the other 4 LEDs are after the resistor, whereas the one here is across the function generator before the resistor. So we're going to start it up now, and you can see what happens during that sweep. It will start at 2 kilohertz and end at 6.5 megs, and then once again go back to 2 kilohertz and start again. Try and zoom in on the LEDs for you a little. So the bright flash you see on the first one is where it drops back down and starts again at 2 kilohertz, and then the intensity is changing across all LEDs up through to 6.5 megahertz. So what we're going to do now is we'll stop our sweep, and I'm going to raise the frequency up until such time Okay, so we're at 3.26 meg at the moment on our frequency, and you can see that the LED across the input is not lit. Just zoom out a bit there, and that is the one that it's the light you see in there is actually a reflection off of here. It's not going at all. So that's the LED that's directly across the function generator. All these other brightly lit LEDs, especially this one here, which is tapped into the middle of the coil, this LED here, which is very bright, is after our 100 ohm resistor. So quite an interesting effect there. So apparently at the moment there's not enough energy directly across our function generator to drive this LED. However, after the 100 ohm resistor, we have the other four all lit up. Number 3 here especially bright. These two aren't too bad. This one's a little dull. And that one's actually connected on the negative rail. That's the negative rail winding about 2/3 of the way into the centre of the coil. So that's quite interesting, I would have thought, this LED not being lit, but yet the other four that are after the 100 ohm resistor and from different points of the coil are lit quite well. So that was our first little experiment. We're going to chuck our scope across the whole shebang here now and have a look and see how it all looks at the scope at that frequency. Okay, so a bit of fine tuning in the frequency range from our signal generator, and we've got our 4 LEDs, different brightnesses of course, but all lit up, and the one across the input is absolutely dead. Channel 1, our yellow channel, is across the input LED. The blue channel, channel 2, is across our first one. Our dark blue channel, channel 4, is across our second LED, and our pink channel, channel 3, is across the last LED. Now I could hook my other scope up, place it on that LED, but we won't worry about it. It is also going fairly bright, but it was the dullest out of the 4, so I just left that one off. So we're looking at the 3 bright ones and the one across the input. So what we're going to do now is zoom in on the scope after I move you around a bit, and we'll see how close we can get you before things turn pear-shaped. Okay. Alright, so we can see why our LED across our signal generator is not illuminated, because the RMS voltage across channel 1 is only 175 millivolts. Across channel 2, which is the first of our LEDs, we have 3.37 volts RMS. Across channel 3, which is the last LED, we have 3.48 volts RMS, and across channel 4, which was our second illuminated LED, we have 3.65 volts RMS. So I don't think I'll be able to get you any closer than that without the oh yeah, maybe. Okay, so we got there, and that's where everything turns pear-shaped. So that's across the signal generator itself, and the first LED that is across the signal generator, 176 millivolts. And if I loosen that off a bit, I might be able to get a bit smoother. 3.37 volts RMS across channel 2, channel 3. Let's go a little bit blurry, isn't it? Oh, there we go. 3.48 volts RMS. Channel 4, 3.66 volts RMS. So, and this is what I was saying about calculating input power using the voltage across the coil and our CBR, in this case a 100 ohm resistor, with the very small amount of voltage we have and what we would have across the CBR, which I can probably use another channel for. Nope, yeah, I'm upsetting the apple cart here. Probably not. I'll just plonk channel 1 on there, which is triggered. That's why it's going pear-shaped. Okay, so the voltage across our CBR is 170 millivolts over 200 over 100 ohms. So very little current, very little voltage. And yet our 3 LEDs are pumping it out, or 4 actually. We just don't have the scope on one of them. So there's our input LED, and it might look like it's illuminated, but it's not. It's just getting the light off of this one. And of course all 4 across our coil are well lit. Interesting stuff. So that's the first of our testing. So what we can do now is swap a few channels over and get an accurate power input from our device and see what it's actually doing. But we'll leave that for the next test, because this video is probably getting hours long and some people get bored with long videos. But that's what we have. Interesting stuff. Alright, thanks for watching guys, and we'll see you next video.